Schneid guy.
So now we're going to talk about the regulation of intracellular cholesterol with a focus on the liver. Notice that we're talking about intracellular cholesterol homeostasis, not extracellular. There are no mechanisms to regulate the extracellular cholesterol in the form of LDL transport or other lipoproteins. So if we start with making cholesterol, we already know how to do that. We're synthesizing it. There's many steps, but HMG-CoA reductase is the rate-limiting step. And now we have cholesterol inside the liver de novo synthesis. Now, the other way that I can get cholesterol into the cell is through uptake from circulating LDL cholesterol, or LDL-C. You see this lipoprotein particle is carrying cholesterol esters, and it binds to the LDL receptor, which now causes what's called a receptor-mediated endocytosis, which means the LDL cholesterol and the receptor are internalized into the cell. There's a number of steps and organelles involved, but we're just going to simplify this and say we end up with some cholesterol inside the cell, and the LDL receptors could go and be degraded, or the LDL receptors can be recycled, and these processes are regulated. Now I have cholesterol from two places. I can get it from the outside, taking it in, and I can make it here, de novo. Now what happens to the cholesterol once it's inside? Well, the cholesterol could be made into bile acids. It's the precursor to bile acids. There's a bile acid synthesis pathway, and one of the important enzymes here is 7-alpha hydroxylase. That's the rate-limiting step and a regulated step. The bile acids then can go into the GI tract, do their function in terms of aiding in lipid absorption, digestion, and then when they get to the terminal ileum part of the GI tract, the bile acids can be recycled and taken back up and reused. We call this enterohepatic recirculation. Entero is the GI tract and hepatic is liver. So this is how that bile acid can cycle around and be used, because it does serve a very important function. Now let's take a look at the regulation. Well, if cholesterol levels go up, there's mechanisms to bring the levels back down. One mechanism is that it can just limit the number of LDL receptors on the surface. We're to simplify this by saying that you're not going to have these receptors getting to the surface. With fewer receptors on the surface, you're going to have less capability to take up cholesterol. Also, cholesterol can have an effect to inhibit its own synthesis. That would also help to bring the cholesterol levels back down. And the cholesterol then could go into bile acids, and that could help lower the cholesterol levels inside the cell. Also notice that bile acids themselves have some regulatory processes that make sense. The bile acids can feed back and inhibit their own synthesis. And these are all very important principles, because we have drugs that can affect the cholesterol synthesis. They can affect HMG-CoA reductase and block it. In that case, cholesterol levels would initially go down, and then you would disinhibit this receptor recycling, and you would have more receptors on the surface, which would allow LDL cholesterol to be taken up more readily, raising the cholesterol back to normal. But now, with more receptors on the surface, you lower LDL cholesterol, which is good, because LDL cholesterol can get into arteries and cause atherosclerosis. Then, if we think about what would happen if we had something that could trap the bile acids and cause you to excrete them out in the feces and prevent this recycling, well, bile acids being decreased in that case would cause an increase in bile acid synthesis, causing more cholesterol to be formed into bile acids, and then you'd have a reduction in intracellular cholesterol, which would then cause more receptors to appear on the surface, and also would increase cholesterol synthesis to bring the cholesterol back to somewhat normal levels. And these kinds of mechanisms can be manipulated with drugs as I described, and that'll be very important consideration when we deal with pharmacological agents affecting cholesterol homeostasis.